Hello everyone. In this session, we are going to discuss about analog and digital data signals. Analog and digital data signals. Data communication refers to the exchange of data between two devices via some form of transmission medium such as wire and cable. One of the major functions of the physical layer is to move the data in the form of electromagnetic signals across the transmission medium. Both the data and signals that represents them can be either analog or digital in form. Analog and digital data. The data can be analog or digital. The term analog data refers to the information that is continuous. Digital data refers to the information that are discrete states. For example, an analog clock that has an hour, minute, second, hands gives the information in the continuous form. The movement of the hands are continuous. On the other hand, digital clock that reports the hours and the minutes will change suddenly from 85 to 86. Analog data such as the sounds made by the human voice take a continuous value when someone speaks. An analog wave is created in the air. This can be captured by microphones and converted that into analog signal and sampled, converted to digital signal. Digital data takes an discrete values. For example, data are stored in the computer memory in the form of zeros and ones. They can be converted to the digital signals and modulated into the analog signal for transmission across media. Digital and analog signals, like the data they represent, signal can be either analog or digital. An analog signal has infinite many levels of intensity over a period of time. Digital signal, on the other hand, can have only limited number of defined values, although each value can be any number. It often simple as 0 and 1. Periodic and non-periodic signals. Both analog and digital signals can take one or few forms, periodic and non-periodic. Periodic signal completes a pattern within a measurable time frames called a period and repeats that pattern over subsequent identical periods. The completion of one full pattern is called a cycle. Non-periodic signal changes without executing a pattern or cycle that repeats over time. Both analog and digital signal can be periodic and non-periodic. In data communication, we commonly use periodic analog signals because they need less bandwidth, and the non-periodic digital signals because they represent variation in the data. Sine wave. A sine wave is the most fundamental form of the periodic analog signal. When we visualize, when we visualize it has a simple oscillating curve, it changes over the course of a cycle, is smooth and consistent, a continuous rolling flow. A sine wave can be represented by three parameters. One is peak amplitude, period frequency, and the bandwidth. The three parameters are described here. One is peak amplitude. Peak amplitude of a signal is the absolute value of its highest intensity proportional to the energy it carries. Period and frequency. The period refers to the amount of time in seconds a signal needs to complete one cycle. Frequency refers to the number of periods in 1 second. And the bandwidth represents the range of frequencies contained in composite signals, that is its bandwidth, and the bandwidth is normally a difference between the two number. It is the difference between the two number. For example, if a composite signal contains the frequencies between 1000 and 5000, its bandwidth is 5000 minus 1000 4000. The bandwidth of a composite signal is difference between the highest and the lowest frequencies contained in that signal. Next heading is digital signal. In addition to the being represented by the analog signal, information also can be represented by digital signal. For example, 1 can be encoded as a positive voltage, 0 can be as a zero voltage, negative voltage. A digital signal can have more than 2 levels. In general, if a signal has L levels, each level needs log L to base 2 bits. For example, a digital signal has 8 levels. How many bits are needed per level? We can calculate the number of bits from the formula. Number of bits per level log 8 to base 2, that is 3. 3 bits are required. In that we have some components, those are bit rate. Bit rate is the number of bits sent in 1 second expressed in bits per bps, bits per second. For example, we need to download text document at the rate of 100 pages per minute. What are the required bits of the channel? Then that is 100 into 24 into 80 into 8 mpbs. Bit length. Bit length is the distance one bit occupies on the transmission medium. We can define something similar to the digital signal. The bit length. The bit length is the distance of one bit occupies one transmission medium. That is, bit length is equals to propagation speed into bit duration. Next one, transmission impairment. Transmission impairment signals transfer through the transmission media which are not perfect. The imperfection causes signal impairment. Three causes of impairments are attenuation. Attenuation means loss of energy. Distortion. Distortion means that the signal changes its form or shape. Noise. Noise is the another cause of the impairment. In this, attenuation means loss of energy. When the signal or a simple composite travels through a medium, it loses some of its energy in overcoming the resistance of the medium. That is why a wire carrying electric signals gets warm, if not heat, after a while. Some of the electrical energy in the signal is converted into heat to compensate for this loss. Amplifiers are used to amplify the signal. And in the distortion, it is just a signal changes its form or shape. Distortion can occur in a composite signal made up of different frequencies. Each signal component has its own propagation speed through a medium and therefore its own delaying in arriving at the first destination. Difference in the delay may create a difference in the phase if the delay is not exactly the same as the period duration. Noise. Noise is another cause of the impairment. Several types of noise such as terminal noise, induced noise, crosstalk, impulse noise may corrupt the signal. Terminal noise is the random motion of electrons in the wire which creates an extra signal not originally sent by the transmitter. Induced noise comes from sources such as motors and appliances. To find the theoretical bit rate limit, we need to know the ratio of signal power to the noise power. The signal to noise ratio is defined by SNR is equals to average signal power to the average noise power. This is about this session. In this session, we discussed about the analog and digital data signals, data and signals. What is an analog and digital data, and what is this analog and digital data signals, periodic or non-periodic signals, sine wave, digital signal, transmission impairment, what type of transmission impairment we have. Those are all the things that we have studied. What is the bit rate, what is the bit length, and what is the peak amplitude, what is the period and what is the frequency, and what is the bandwidth, and periodic or non-periodic signals, what is it analog data and what is the analog signal, what is the digital data and digital signals, etc. things that we have studied in this session. Thank you.